Good morning, I am Srilekha, Department of Chemistry. On the previous sessions, I have discussed about how the nanomaterials can be displayed and how the types of nanomaterials can be used in these functions of the synthesis of method. So here now I am going to talk about on the topics of the synthesis of nanomaterial by using in the formation of solvothermal method. So this is a solvent chemical technique method we are using in this foundation. So the solvent thermal method we are using in this, here we are taking as an in the formation of an autoclave method. The autoclave method is used to form in the 50 to 150 degrees Celsius. We have to maintain throughout this experiment. So whenever we have this experiment, by using in the formation of a chemical based solvents. So here we are adding a zinc acetate dehydrate when mixed with the 2-propanol. So this is the chemicals we are using as a starting precursor material, that is the 10CHT101-CO2 plus H2O when mixed with this formation of 2-propanol. So here the zinc acetate dehydrate when mixed with the 2-propanol is a solution of starting material. At the same temperature and the pressure we are using the constant temperature and the pressure we are maintaining at a 50 degrees Celsius to form the solution. And again from the solution we have to add the sulfate sodium hydroxide as a catalyst into the solution. We are adding into this, and to form the reactions can be continued by using in the formation to the below the 0 degrees Celsius to the formation of sodium hydroxide. So here the 50 degrees Celsius we are heating at a temperature, and then we have to cool down the reaction for a 0 degrees Celsius, and then we have to add the sulfate sodium hydroxide into the solution at the same temperature and the pressures. So again, and the next view from the reaction, we are going to move on with this zinc acetate. The removal of the water molecules with this reaction can be carried out in this by COO2 group. When reaction with this H2 group, we have to remove the water molecules. And from this water molecule removal of the second process, we are going to convert the zinc oxide growth particles. So zinc oxide growth particles we have to maintain in this formation. So for that we are adding as a solvent with this again 65 degrees Celsius at a temperature to maintain this formation at a constant temperature to pressure. So and then we have to arrest the reaction by using in the formation of as a capping agents. For that we can to add the capping agent as a 1 low decay thiol solution to form this reaction. So we are adding the 1 low decay thiol solution into this reaction at a temperature at 50 degrees Celsius to maintain the to arrest the reaction, to stop the reactions from this growth of zinc oxide, nano zinc oxide growth particles. So here from the third reaction we have to move this structure formation. The deposited zinc oxide growth can be deposited from this reaction as a zinc oxide nano rod structures can be made deposited at this layers. So here the zinc oxide nano deposition with this material can be reflected by using in the formation of the ceramic particles and in the use of the layer coating particles and from the formation of the zinc oxide particles. So the particles can be separated from this zinc oxide particles is due to the formation of the RS the zinc growth of the 1 low decay thiol solution as a capping agent. So here the capping agent plays a major role in the formation of the nano zinc oxide growth particles. So some of the growth particles can be removed by using in the formation of the temperature and the pressure at 50 degrees Celsius. So the temperature and the pressure can be maintained by using the formation of the zinc oxide growth particles. So the zinc oxide growth can be carried out by using the formation of the substance derived in this layer as a coating layer. The coating layer can be expanded by using as a formation of zinc oxide. So the zinc oxide layer is substituted by in the formation of the zinc using the formation of the removal of water, that is the 10CHP CO2 plus H2O. So this is the formation how the solvothermal process can be carried out the zinc oxide nanogrowth particles at a temperature and pressure. So the applications can be used in the solvothermal is nothing bad. The varieties of application, it is a very low cost method, and that's only the solvent method we are using in this experiment. No, the experiment can be carried out at a high temperature as an inert atmosphere. So it displaces the formation of the zinc oxide growth particles in these reactions. So the advantages of this by using this solvothermal experiment is it is very easy to operate with these reactions, and the temperature and the pressure can be maintained at a very low temperature as a 50 degrees Celsius and a 65 degrees Celsius temperature. To know more, we can cannot be used in this formation of a high intense laser or the light can be irradiated from this solvothermal process. So the zinc oxide particles can be prepared by this using this method. Thank you.